Uh, so today we will have a session for the triple quadrupole mass analyzer, and this will be the last session of this triple quadrupole mass analyzer. In this one, I will tell you about the preparation of the sample for analysis, and after that, how can we draw the calibration curve using the triple quadrupole mass analyzer and the experiment, and how can we perform the quantification using our LC analysis, which we have performed previously in the MRM method. So in this slide, you can see that you have to first prepare the stock solution by weighing out the exact amount of the standard that you want to analyze. And after that, you have to dissolve that solution in your sample using a high pressure liquid chromatography grade solvents. And after that, you have to prepare the stock of that solution. And to prepare the samples of different concentration, you have to take sample directly from the stock solution, and this technique you will use for the preparation of the sample of TQMS, and it will be termed as the serial dilution from the stock solution. And later on, we can do our analysis. And this is the illustration how you can do that. Actually, this is a stock solution. And from this stock solution, you can take different amounts and you can dilute them directly into different other vials. And this will be your sample preparation technique for the TQ samples. And after this, I will show you how you can do the quantification and how you can draw the calibration curve. And it will be done using the recorded video, which was recorded by the Anjan. So now I will share that thing.
After completing the quantitative analysis, open target links for data processing. Click Edit Method to create a new method. This button is for adding compounds, and this button is for deleting the created compounds. Enter the compound name, and set the rotation time by dragging the chromatogram with the mouse. And set the concentration of standard level to A. Other parameters can be adjusted according to the sample. And also you can extract fragment ion in here. You can use it. And save the created method. Once the method is created, select the analyzed standard to create a calibration curve. Then click Process Sample and load the previously created method file. By selecting each compound, you can check the chromatogram and the assigned area. The assigned area can be manually adjusted. And you can save it. If the areas are not automatically adjusted, you can use AdPic to manually set them. Then a calibration curve is automatically generated based on the entered concentration and area value.
So this was all. How we can do the calibration? How can we draw the calibration curve using the triple quadruple mesh analyzer? And from this, you will get equation which will justify your analysis. And after that equation, you can use that for the quantification of the unknown samples. So this is all. If any of you has any question, please let me know.
Can you explain the sample preparation? Like how can we prepare the stock solution again? Like just how to prepare stock solution and then how to dilute.
Is it visible?
Yes.
Okay. So actually, you have to prepare a stock solution. Let's say here, uh, let's say that you want to weigh out 10 milligram of the standard solution, and you want to dissolve into a particular amount of the solvent. So it will present your parts per million amount of the stock solution. Let's say it is 1000 microgram per ml. So and total volume of your stock solution is 10 ml. But for analysis, you need only 5 microliter or 10 microliter, but you need 1 nanogram per ml, but not the 1000 microgram per ml. What you have to do, you have to take from this stock solution and dilute it into 1 nanogram per ml. And further, when you need 10 nanogram per ml, again you have to take from this stock solution which you have prepared already. So this is what I wanted to say. And it is also presented in here, like you have to take always from your stock solution. You cannot do this, like you prepared one solution from the stock solution and you cannot dilute this solution into further dilutions. If you do this, maybe uh, because of the human error, you were unable to get proper amount of this solution, and further your calculation will be wrong. But if you have prepared this stock solution with accuracy, then all of your concentrations will be well representing your stock solution and its dilution. Your
For
mic.
how, for how long can we store this stock solution or we have to prepare fresh every time?
I don't know about that because it depends upon your standard. If your compound is not stable in the aqueous or your solution state, then you might have to prepare fresh every time. But if it is stable, then you can keep your stock solution maybe up to 1 week. After that, it is better to do this. But I don't know exactly what is the time limit for this.
Okay.
Really, I am agree with Imran. So when he said like to preparing the standard solutions from the stock, we need to be extremely precise because I recently did and my small mistake. Actually, the curve should show the R square value more than R square 0.99. So otherwise you will get the number and wrong values. So when you are preparing your 5 standard solutions, you need to be extremely precise and try to not to make any mistake. And I think it would be good if you prepare every time and you know that you are like you did right. So if sometime it will stay, sometimes the concentration or the metals kind of fly away. That's why I suggest if you have if you want to prepare like over the some time like 5 different standard solutions, it would be good if you do again from your stock.
Yeah, a question. Can you hear me?
Yes, we can hear you. Go ahead.
I have a question about the video of that engine shows that in the method creation we have to select concentration A always. Is it concentration A always selected or concentration B or C can be selected?
Actually, you have to give it some starting point. Okay. It is just to set your method. So it is a convention to select concentration A. And when you will put that method, and you select 5 different LC analysis that he selected afterwards for creation of calibration curve, then it will take it in such a way that it is not linear concentration. I have to set this point as 1, another concentration as 0.2, and then so on, and then it will draw the calibration curve. If you put it as constant, then it will not draw the calibration curve.
Okay. Now we have to put select concentration A always and the zero concentration in the concentration value, right?
Uh, Actually, we don't go in the more details because it depends upon your analysis, but we don't do 0 or 1 or something, because for that thing, that whether the concentration was 0 or whether it was a blank that we selected first or something else, that we do in the LC analysis sequence. Let
Okay.
me share that video again.
Yes, I have the show that
Can you
100,
see
500.
can you
Yes,
see my screen of
yes, yes,
Anjan's video screen?
yes, yes.
Okay. Can you see in here? She put that this is 100, this is 500,000. So your method will take these concentration into account. Okay.
Okay,
You don't need to put in the method those quantities.
okay, okay.
Yes.
I understand that. Thank you very much.
Okay, thank you. If you don't have any question, then I will say goodbye to you, and it will be available in the NAS server in the EMS training 2024 and 25 session. You can consult this for your undertaking and whatever you want to do. So thank you for listening.